Hi, I'm Tashi Poe. I work in an undergraduate lab here at JMU with bioplastics. Bioplastics are safer than usual plastics, which are petroleum-based and are kind of like glitter. They degrade into microplastics, and microplastics get everywhere you don't want them, like animal meat and human lungs and placenta. So I work with bioplastics made from starch. So I've been making them with corn and potato starches, amylopectin, which is a carbohydrate and is a component of starch. And I use a very simple and safe procedure. Eventually what we want to do is take this into the general chemistry labs and have them start making bioplastics that we will eventually test and degrade using beta amylase. So I've been developing testing procedures for the chemical and physical properties of these bioplastics, and I've found a way to make it accessible to the average general chemistry student. And ultimately the goal of this is to make an infinitely recyclable bioplastic, because right now we have bioplastics, even the ones that are good, may not be infinitely recyclable, may degrade after the first recycling procedure, and so we're trying to make something that's even better. And the way that this would work is we would hopefully be able to make bioplastic directly from maltose, which is what chemical you get when you add beta amylase to starch. Beta amylase breaks down starch like a mother bird feeding its baby birds. It chews up starch, digests it, breaks it down, really, not digests it, but breaks it down, and then spits out maltose. So if we can find a way to polymerize maltose into a plastic, then what we can do is make that plastic, break it down using beta amylase back into maltose, and then repolymerize it in that infinitely recyclable loop. Even if we can't figure out a way to polymerize maltose, we can make these bioplastics that are better for the environment from starch, and then break them down using beta amylases into maltose that we could then use as chemical feedstock to do other chemical reactions. And my work is not going to be the one thing that solves the plastic crisis in America and globally, but it could help other researchers and help them figure out what they're doing with their work, help them prime their procedures, and ultimately find us a way to get away from petroleum-based plastic once and for all.